In this topic, we're talking about hardware, but this is a programming course, so what good is the hardware if you can't run a program on it? So we're going to look at how the hardware that we've been looking at actually loads and runs a program. For this, we're actually going to use the diagram from the course. You can find this and all of these little steps listed out just above this video. Now this is a little bit of a simplified model that we're going to be looking at, but I will introduce where there's a couple of hardware and software things in here that aren't as important for our purposes, and I'll explain why understanding this simplified model is so important at the end of the video. So let's just take a look here. This is representing secondary storage, and the first step is actually to load the program into memory. This is memory. You may recognize that from an earlier graphic in this topic. And it will actually load not just data but also instructions, and that is step one. The next step then is the instructions and data will go to the CPU. The CPU will then perform its calculations and send the results back into memory. And this happens over and over again, so 4 represents this loop. This is basically the most of what your computer does, and this is the most important thing to understand here is that you have data and instructions here that go to the CPU. The CPU performs its calculations, its operations, executes the instructions using that data, and then sends the results back to memory. Of course, you also have your users down here, so you have some output, which is here 5, and then input 6 that will occur as necessary depending on what you want your program to do. And so step 7 here is that 4, 5, and 6 repeat as needed. So it will go through the cycles from memory to the CPU, back to memory, around and around, and when needed it will display things, and it will also get input from the user when needed, and then go ahead and go back through memory to the CPU, back to memory. Okay, I said that there were a couple of other things here. This is a simplified model, just so that you're aware. There are a couple of important things that aren't important for our purposes, but just so that you know, there are some things in here with the CPU that are that make this model more complex. Your registers and cache, they're right here on this piece of hardware. They actually serve as kind of like really fast memory, so that this full cycle doesn't have to happen. And then on the software side, you also have your operating system, which controls how all of this is done. Okay, and also, you know, load your program from secondary storage, and actually in some programs, not necessarily for this course, you would be writing back to secondary storage again. However, this is the model you need to understand, and let's review that. Again, you load your program from secondary storage, the first instruction, and then the data goes to the CPU. It carries out that instruction, the results go back to memory, and that cycle continues, output and input when necessary, and then it goes back to memory to CPU, back to memory again. There is an 8 here, and that's just showing where once the program completes, it's I hate to say removed from memory, because not necessarily that gets into the complexity with the operating system exactly what it does with it, but essentially this memory is freed up once your program is finished. So you may have noticed before, sometimes you'll be running a program and close it and then say, oh, I need to open it again, and it opens very quickly. That's just because the operating system knows that that some of that stuff is still there, it can use it and everything. But our cycle here with output and input is what you need to know, and this is why. When you go from the memory to the CPU, you need to know what data and instructions need to be sent, and that is the essence of programming. And also you need to know where these results should go back to in memory. This seems pretty daunting. Don't freak out too much, because this is C++, which is a higher level language. You'll learn you'll learn everything you need to know in this course without having to worry about getting into the nitty-gritty of that. Oh, and also it's going to be a lot easier with the whole output and input, but you also need to make sure that's done correctly and that any input goes into the correct place over here. But knowing which instruction and data goes to the CPU next is the essence of programming. And in the next topic, you'll learn all about higher level languages and how programs are created. However, we still have a little bit left in hardware, so there's a couple of sections left in this topic on binary, because to be a good programmer you need to have at least a rudimentary knowledge of how binary works. This concludes another video for Introduction to Programming with C++, brought to you by LogiKomp. You can access the full course by going to the course homepage at logikomp.com/introcpp. While we are proud to offer this course free of cost to individuals, we do ask that if you continue to use the course, that you support its production and maintenance by making at least a small purchase from LogiKomp Domains and Hosting. You can pick up a custom domain, renewable annually, for around $10 at logikomp.com/hosting. Thank you.